Welcome to LabMinutes.com and our lab video series in Cisco ASA 1000V. You can find a complete list of ASA 1000V video on our website by clicking on the link above and sign up for our newsletters to receive the latest video update. One thing that's unique on an ASA 1000V compared to a physical ASA is the concept of security profile and security profile interface. For every security profile you create on the VNMC, there is a corresponding security profile interface automatically created on the ASA. A host that has been assigned a security profile essentially sits behind this interface and has the associated security policies applied to its traffic as it crosses the ASA. Security profile interfaces is usually tied to an inside interface and has security level of 100. In this video, we will create the basic security profiles in Cisco ASA 1000V in VNMC mode. We will configure basic Ingress ACL and port address translation and apply them to the host behind the ASA. Here's our lab setup. So we already have a pair of redundant ASA installed from our previous lab videos. Here we have 3 test servers, Web1, Web2, and DB1. And we will be creating 2 separate security profiles, one for the web servers and one for the database server. Now for the web server security profile, we will do a very basic Ingress ACL with the permit all and a port address translation to the outside interface, which is the .16 IPs of the ASA. Now for the database server, we'll do Ingress ACL that only permits ICMP only traffic, and we will path the traffic out to the IP of .18. Now on the outside of the ASA, we have it connected to a Nexus 1000V and then to the upstream switch, which is the gateway of the VLANs, and then it will have access to the internet also. So we're going to start off with creating an Ingress ACL. First log into or get onto the VNMC web interface. Now going under the policy management and then service policies, and we're going to get under the app one, which is where our ASA 1000V is currently located. And you expand the policies. Under the policies, there's a option for the ACL. And first we need to create an ACL policy. And here we're going to do for the web server, which we say we want to do permit all. So you can see there's some ACL there already that we used back in the VSG video, since the VSG also used ACL to enforce the access. So now we'll give it a name, ACL web to outside, because it's going to be ingressed on the inside interface. Now as first the rule, I'm just going to repeat the name web to outside. And instead of drop that's there by default, we'll choose permit. And we're going to leave everything by default, which implies that's any to any for everything. And make sure I spell that correctly, web. And click OK. Once we have the policies, we have to create a policy set that we can use to apply to the edge firewall, or actually it's more of a security profile. So here we'll give it a name, also we'll call it something like from inside app 1, and this is going to be for the web. And then we'll select the ACL web to outside. Okay, move it to the right and click OK. So that's the Ingress ACL for the web server. Next we're going to do Ingress ACL for our database server. So again, we go under the ACL policies, we create a new one, and let's call this time ACL DB to outside. Then we'll add a rule, and we can just follow the same naming convention, just say DB to outside. And now we want to permit is ICMP traffic. So here we click permit, and instead of any protocol, we'll make sure we select ICMP. So let's look for ICMP over here, right there, and we'll click OK. And you can see right here protocol is equal ICMP, and then OK. And then we'll go to the policy set, add an ACL policy set, and we'll call this one from inside app 1 DB, and then we'll select DB to outside, click OK. We also will need to create an Ingress ACL on the outside interface to permit the return traffic. Right now we're not quite dealing with the inspection yet, so we're just going to permit anything coming in from the outside, just for our testing purposes. And since it's so generic, we're going to do it up here at the tenant one. Go into the policies, and if you look under the ACL policies, we already have an ACL called permit all. So all we need to do is to get under the policy set, add a new ACL policy set, and call this one from outside permit all. And then we just use existing one that we created previously and just basically permit IP any. So that's all we need to do for the Ingress ACL. Next we are going to create NAT policies for our outbound traffic, and we're just going to do a simple pat to a single IP. For the web it's just the interface, and for the database it's going to be .18. So here let's go back to the app1 level and go to the NAT, and the concept is very similar. First you need to create a NAT policy just like the ACL, and for the web server let's call it NAT app1 web. Make sure state is enable, and then we'll add the rule, and for the name we'll call it pat web to interface, since we're going to pat out the web traffic to the interface IP outside interface of the ASA. Source and destination will keep it simple as any, and if you scroll down, here we have an option to do static or dynamic. Since pat is considered dynamic, we'll pick dynamic. And we need to create an object group, since currently we do not really have a object for the outside interface of the ASA. So right here, click the add object group, and then for the name we'll call it map IP 172.16.128.16, which is the outside interface IP of the ASA, and then we'll add IP equal 172.16.128.16. Click OK, then OK. Now that we have the object, we drop down. You can see the object group we just created shows up on the drop down, and go ahead and select that. If you scroll down, might as well just there's a couple checkboxes down here that you can do, and always doesn't hurt to do enable DNS. Okay, everything else will leave the same since we're not doing any destination. Address translation here, we'll leave that alone. Now click OK. Then click OK out of that. And then we can go to the NAT policy set and create a NAT policy set. We'll name it NAT app1 web, and then we'll choose the one we just created. Okay, next we're going to repeat the same process for the database server. So add NAT policy, NAT app1 DB this time. We'll add the rule, and we'll call it pat DB to 172.16.128.18. Again, for the source and destination, we'll keep it any. NAT action is dynamic, and again we'll add the object group, call map 172.16.128.18, and the IP is 172.16.128.18. Click OK. Sure those are correct, and then we'll choose it under the translated address option, and then again enable DNS. Click OK and OK, and then we create or add a NAT policy set. We'll call it NAT app1 DB, then remove that over. Alright, so now that we have both the Ingress ACLs and NAT policies created for both of our web and database server, we can put them together under your security profile. So if we go under service profiles, and then we want to do this at the, again, app1 level, and under the edge firewall, here we have the edge security profiles. Okay, so currently we do not have any of those, so let's go ahead and create. The first one is going to be outside. We also need a security profile for the outside interface, so for the name we'll call sec profile app1 outside. And all we have for now is the Ingress ACL. Here in the drop down, from outside permit all, say yes, and let's make sure it looks correct with the permit any. We'll click OK, and then we add another one for the web interface or web servers. We'll call app1 web, and Ingress ACL is from inside app1 web. Again, just double check permit any, and for the NAT we'll select NAT app1 web, and that should be our pat rule. Okay, click OK, and then we'll create the last one for our database server. So profile app1 DB, Ingress inside add, actually it should be DB. And then for NAT, it's NAT app1 DB. Then we'll click OK. So now we need to assign the security profile we have created to the interface. For the outside, we can assign the security profile directly at the edge firewall. So right here we go under resource management, resources, or actually manage resources, and then trying to find the managed firewall that we have configured already. So right here, tenant 1, DC1, if you go under the edge general and scroll down and locate the outside interface and then click edit. And you can see right here you can assign the security profile to the interface. So click select, and this one's going to be for the outside, so app1 outside. Click OK and then save. Now for the inside test servers, the way the security profile is going to be assigned to those is through the port profile on the Nexus 1000V. So now what we have to do is to get onto the Nexus 1000V here, clear that, and the first thing is to make the ASA 1000V known to the Nexus 1000V. So the way to do that is to create a Vservice node, and then to give it a name, let's use the actual ASA name, which is follow the organization path. So app1, tenant 1, DC1, app1, and ASA1. And you have to specify the type. And here we have various options, but we're dealing with ASA, so we specify the type ASA, and then we'll give it IP address. And this is the IP address of the inside interface of the ASA. For us is 10.0.1.1. So not the management, but the inside interface. And then for adjacency, it's going to be layer 2. And this is for the VLAN that the inside interface is connected to. And for us, it's a VXLAN with the bridge domain call VXLAN 6010 tenant 1. Okay. So now we have to create a port profile that we can assign to the test VM. So I'm going to look for an existing port profile that we are currently using for VXLAN 6010, and then we're going to associate that to the security profile. Okay, so I have a port profile called VM VXLAN 6010 tenant 1, enter, right there. So let me bring up a notepad, copy this, and then notepad, then paste, and then we're going to modify this. Let's call this one app1 web. So port group's the same, mode access the same, switch port access, bridge domain's the same, no shutdown, state enable. Okay, so let me go ahead and copy and paste that. And then on top of that, we have to specify the organization level. So for us is root, tenant 1, DC1, app1, and that's where our edge firewall ASA 1000V is located. And then we have to tie that back to the Vservice we just created earlier. So node, see if we can find it real quick with the Vservice node name right here. And then we have to let them know the name of the profile. So for the web is called sec, if you remember, profile app1 web. And we're going to pretty much configure a very similar port profile, but this time it's going to be for the database. So again, let me copy out this. Instead of web, we call it DB. It's going to be the same edge firewall, but different security profile. Okay, so that would be DB at the end. Since we created with a very similar name, we'll copy and paste. And now we have the 2-port profile. Now we're going to assign the port profile first to the web server. So we go back to the vCenter, and what we can do here is to get under the networking. We just want to do both at the same time. Right click, and then on the Nexus 1000V, go manage host. We know the 2 web servers on the first ESXi. Click through this to where you can migrate the virtual machine networking. And down here we have web 1, and then let's search for the, there you go, the port profile we just created for the web. Click, then go next, and then go finish. Okay, give it a couple seconds, it should be done now. So if you go back to the Nexus 1000V, let's do a couple show commands. before we start doing some testing. So we're going to do show Vservice detail, and you can see right here with the ASA is active on the module 3 where our test VMs are located. The license count is 2 because it's based on the CPU socket, and module 3 is the only one that has an active VM that's currently utilizing our ASA 1000V. State is active. The VLAN is the 6010 VXLAN. I also have the IP, and here's our 2 web servers, 1 and 2. Okay, so that tells us that the VSM, or the VM, actually has a connectivity to the ASA. So now if we go to the ASA themselves, looks like the session timeout, so let me restart the session. Let me log in, and then do show run interface. And you can see, in addition to SP001 that we might have seen in the previous video, now we have SP2, SP3, and SP4. SP2 is being used for the outside security profile, SP3 is for the web security profile, and SP4 is for database security profile. As I've mentioned, for every single security profile that you create in the VNMC, there's a corresponding security profile interface created on the ASA. And you can do show name if, same thing right here. And you can see by default all of them have security of 100. Okay, let's look at some of the ACL and NAT configuration that we did on the VNMC and see what it looks like on the ASA. So you can do show run access group. Let me kind of expand the windows. Then again, you can see here we have our Ingress ACL for the outside, and then we have the Ingress ACL for the web and the database. Okay, and you can do show run access list. And we can just look here from the outside is permit IP any. For the inside web, it's also permit IP any. And then from the inside DB, it's permit ICMP any. Alright, the other thing that we configured was a NAT. So we can do show run NAT. And here we can see we have 2 dynamic NATs. And VNMC or ASA automatically chose to use the twice NAT type in the section 1, if you're familiar with ASA 8.3 and above NAT syntax. And for the SP4, which is our database security profile interface, the traffic will be padded to .18, and for our web traffic, it will be padded to the ASA outside interface IP. Okay, so that's what the config on the ASA looks like once it pushed down from the VNMC. Now let's do some testing. So here I'm going to bring up a console to the Web1 server. First, so we can ping the ASA, which is 10.0.1.1. And you can see that we can ping that. Next, we're going to ping the Web2, which is the IP of .33. You can see we can ping that also. Next, we're going to ping the outside ASA outside interface, the gateway, which is the 128.1. So let me log or bring up that switch. Let me clear the screen. And let me do or show IP interface brief. And you can see right here, 128.1 is up. And then they can do a debug, IP SCMP, and just to monitor what IP the switch will be seeing the packets coming from. And then we'll ping 172.16.128.1. So you can ping that, and let me stop that right there. If you go back here, you can see the switch is seeing the packet coming from the 128.16, which is the ASA outside interface, since we padded the packet. And at the same time, if you go back to the ASA and do a show xlate, and you can see right here, our Web1 IP, which is 1.32, has been translated to 128.16. And at this point, since we have the pad working, we should be able to ping internet also. And you can see that we can. One last test we want to do on Web1 is just to browse the internet. And we currently have the DNS of this particular server pointing to the public DNS. So we can just try to go to Cisco.com. You can see we have no problem hitting Cisco.com. You can see there's a lot of translation as well as show connection. So that's for the Web1. Now, since we haven't really moved the DB1 server, or assign the port profile for the database to the DB1 server. I just want to show you what it would look like when you have a host that's trying to get out or go through the ASA without having a security profile associated to it. So here we can try to ping the ASA. You can see we have no problem pinging the ASA interface, which is ICMP that terminates in the ASA. But as soon as you're trying to ping through the ASA, although the host has a default gateway pointing to the ASA inside interface, you can see the ASA would not let the traffic getting through. So basically any host that does not have a valid security profile associated to it would not be able to pass through the ASA. Let's go back to the vCenter, and then we're going to move our DB1, so edit settings, to the correct port group or port profile. So right here we move it to the DB, we'll click OK, make sure it's completed, and then we go back here and we're trying to ping 128.1, and you can see we can ping successfully, and at the same time on the background, the switch here, we have a debug ICMP, and now the switch is seeing the traffic is coming from 128.18, which is the padded address we assigned to the database server. Well, we can try to ping 4222, and that should succeed as well. But if you're trying to go to a Cisco.com, basically browsing the web, and you can see we cannot really get out. And if we jump onto the ASA real quick and do show log, show log deny, and you can see right here .34, which is the DB1 is trying to go out to 4222 or trying to do DNS lookup, and that is being denied by our Ingress ACL for the database, since we only permit ICMP. Okay, and the last thing we want to test is to basically just ping the two web server at the IP of 10.01.32 and 33. So you can see any traffic stays behind the ASA or within the same VLAN doesn't really get inspected or enforced policy by the ASA, and this would be a responsibility of a VSG. So ASA only concerns as far as from the inside trying to get out to the outside. Okay, so here we have successfully configured a basic security or edge security profile with the Ingress ACL and port address translation, which pretty much wraps up our video on ASA 1000V basic edge security profile and policies in VNMC mode. Please visit our website to view an extensive list of our lab videos and sign up to get access to additional lab contents. Thank you for watching LabMinutes.com, and I'll see you guys in the next video.